Hello, AP Chem heads. Here's the thing. Instead of giving you a paper review for a Chapter 6 quiz on later on this week, I'm going to go ahead, I'm doing a video review, because what I want to emphasize for this particular quiz is not so much the math, more the concepts, more understanding the ideas. So therefore, many of the questions, in fact, almost all the questions are going to be multiple choice, with the exception of one problem solver. One problem solving. So what I want to do is go through the notes so that you can mark which pages of the notes should you be really concerned about, because certainly there's quite a few in here. Okay, you should understand what is thermodynamics, being the study that it is. Okay, whoops, whoa, that shouldn't be happening. All right, okay, let's go back. All right, so moving on here for thermodynamics, we talked a little bit about the idea of energy. Okay, you should know about energy, you should know about the idea of a state function, that it doesn't matter what path that a reaction is going to take or a process is going to take when it's going from point A to point B. Okay, whether it's a straight path or it's a curve, it doesn't matter. Okay, system and surroundings, that should be something that you should know. Just typically the basic idea that in chemistry, we normally are going to deal with the system. I'm not going to be asking a question of, give me an example of a system or surroundings. I'm not going to do that. Okay? Endothermic and exothermic reactions. Yes, yes, yes. That is very important idea. Remember, it's a question of where is this energy going? If energy is being released, we call that an exothermic reaction. If it is being absorbed, that's an endothermic reaction, and you have some examples right here to see for that. Do I want you to memorize the graphs? No. Nope, not worried about the graphs at all. Okay. Direction, yes. Yes, I would expect for you guys to know the direction in terms of energy. If the energy is negative as the number, it's an exothermic reaction. If it's positive, it's an endothermic reaction. So something that you might want to think about here to remember negative exothermic, think about how we have to be careful with what we say to people. Because we could say things that can harm people, right? But if we are taking in the good things that people have, it's a positive thing. So endothermic, releasing, endothermic, you're absorbing. Okay. We talked about systems and surroundings. Okay, the same basic idea for heat and work. Okay, first law of thermodynamics, I would expect you guys to understand that energy, the energy of the universe is constant. You can look at it, energy is not created or destroyed. It does change forms though. It absolutely can. Great example of changing forms. Think about the regular, you get the radio signal to your cell phone. Your cell phone then takes that, changes it into electrical energy. So from radio signals to electrical signals, electrical energy, and then from electrical energy it changes into sound waves, which that is a form of energy if you think about it. So that would be an example of how energy changes form. Okay, we be familiar with Q being heat, that Q represents heat in this case. Okay, talked a little bit about the idea of work. Yeah, I would know what work is, force times distance, and that would be a good thing. Work being sign, I'm not going to worry about that for this quiz here. Enthalpy, yes, I would want you to understand the idea behind enthalpy is the total heat content of the system. Okay, that's a pretty key thing. That's why we get to see a lot of those delta H's as we move on later on. Okay, am I going to give you formulas for the quiz? Yes, yes I will. Okay, but really you're only going to have one problem solving problem. Okay, really one math problem this time around. So I'm anticipating that for some people, they may think, yes, wonderful, I kind of get the idea, but the math is not I'm a little shaky on the math. Well, that's okay. There's only going to be one math problem this time around. The name of the game here is that we're just moving along here through chem. Calorimetry, yes, I would want you guys to understand the concept of calorimetry. Okay, where we have a system where we got water, we have a thermometer, it has a certain temperature. We take an object that has already been heated up, so we would expect it to have a higher initial temperature than the initial temperature in here. We put the object in here, and then we watch as the system with the object and the water is now coming to an equilibrium. And that's why we could use a coffee cup, because the styrofoam prevents the heat from escaping. So that's something that's very useful to know. You guys should absolutely know, oops, it's not doing it here, Q equals MCAT. That is a very important formula. Q is energy, equals, that's obvious, M meaning mass of the object, C is the specific heat of the object, yes, you need to know about that, and the delta T, where it's T final minus the T initial. That's pretty much it. Okay, so in this case here, this is just more examples of doing that. We've worked with the coffee cup calorimeter in the lab, which you guys will be working on the lab report as well. In another video, I went ahead and I worked through these two examples, and I went through detailed explanations as to how and why we did those. You can check that out on another thing. Okay, the bomb calorimeter, yeah, this is a fun one. And basically with the bomb calorimeter, we can't get one here, but this is how they determine how many calories there are in food, in soda, all those things. It's really wonderful to have that. And it works on basically the same idea. How much heat does the water absorb from the burning, or you may want to look as blowing up, the food that's in there? Okay, I am not going to worry about properties this time around. Hess's law, I want you to understand the basic idea behind it. What is the state function with this? Okay, because that is what enthalpy is. Are you going to be doing any Hess's law on this quiz? No. Are you going to be doing any on the final? Yes. Am I going to do a videotape on how to approach Hess's law's problems? Yes, I will. At some point in the future, I promise. Before final exams, obviously. Okay? All right. And I think, let me see, I want to make sure I got everything. Yep. All right. I did make a videotape talking about the standard enthalpies of formation. All right. That's not going to be on the quiz either. Okay. And I believe this is it. All right, so I wanted to make sure that you guys knew which specific slides to pay attention to. You are going to have one problem out there, one math problem. I kind of been hinting about the Q equals MCAT equation. That probably would be a big one. And if you forgot what Q equals MCAT, I still have this left over here from my previous video. Again, you can go and check that out. I worked through the problems in the notes, okay? So Q equals MCAT, this formula, I will freely give it to you. If you need the specific heat for the material, I will also give that to you if you in fact need it. Okay? All right, ladies and gentlemen, I hope this review will help you guys out. All right, I specifically targeted specific slides for you guys. Just feel free to run through them again. All right, take care.